She's a piece of shit. Good morning, people. Can you hear me? Well, it's just Carolini, so can you hear me?
Yes, it's all good.
Okay, cool. We're not in the library. We're in 205. So next week when you come in, it's just opposite the library, 205. So we have our own room. Database is in here. Everybody else go away. Databases, database. Okay, so let's just see if I can get that's that. Get rid of that. Workbench. Okay. I'll just wait a few minutes because I guess people will be delayed in with buses being late and so on. How many people have we got online now? Just one. Nobody wants to be in databases on a Wednesday morning. We've got three of you. Three of you. We should have how many? 12 should be in the class. So 24. I can understand.
Being honest, the old time was much better.
Yeah, well, yeah.
I know maybe you're not available, but yeah. The first voice at like 5 AM every day. Were you?
Yeah, I'm not available because they make me teach another course here. So they had to switch your time. Because one of the other teachers left. So I had to take two loads. And I couldn't do both at the same time. So I'm now doing 11 classes. That's a big load. How many there are? 7, 8. Yeah, 6. Yeah, 6. No matter.
Come on.
That, I have a grant. I have a place from all the last semester. So I need to do a repeat test, already test, because I lost the date. So hopefully we will be ready to watch the classes again and do our repeat test, or I just need to do the test straight away.
Which test did it? I can't even remember.
It was about your last subject in the last semester.
But I did 8.
Database analysis, yeah, but be honest, it doesn't matter the subjects, all those important, like when you repeat the subject. So.
I don't know, I've never had to do it. Fucking superstar.
What did I get, man?
Yeah, that's not true. Microsoft exams and resit and resit and lots of that stuff. Back in the day in the 90s, 98, 99, the Microsoft exams were almost unpassable. So things about NT servers and I passed them, but Exchange server, no way could I pass that. I tried it 3 or 4 times. Because the question, each answer was about 3 lines long, and there was 4 or 5 of them with just a few words changed. So it took you so long to work out what the answer to the question was. And then the next question was almost the same as the previous one, but that's in group and that's in local. You go, shit, what did I ask in the last one?
How much time do you have for this kind of tests?
I think we have 2 hours.
2 hours? Bro, do we have a kind of high school exams when you are in the last year of high school? It's really tough because you have 2 days for the test and it is like 5 days on Saturday and another 5 days in Sunday. At the end of Sunday, we're like getting crazy because we have to do like also we got together.
Yeah.
And yeah.
Okay. I'll talk about databases in general until somebody comes then. Because, I'll put the the QR code up. The question is, how do you do the way I write the repeats is that you should know exactly the same as what you knew for the main exam. Okay, and all I do is reword the question, or sometimes I put a nice easy one in as well to give you a chance. If you find me the subject, I'll tell you what to do.
Okay. And this big problem is I don't know if I need to do another CA or just do a repeat test.
Okay, so it depends whether it's an exam that you missed or a CA you missed.
Okay. Let you know.
If it was a group CA, then you have a single CA task.
Yeah, it was
Okay, so
no rush. Next class I can go with the how will you like this? That I send you.
still only one online. Dear.
Hi Josh, I'm here.
Oh, hello,
I'm here. I'm online today.
Bruno.
Yeah, I
Okay,
was supposed to be there, but I lost the time.
yes. You looked out the window and saw that it was wet and you thought, no way am I going out in that.
Yeah, and in my computer it was showing like the weather was giving the description that it was sunny, you know, like and when I opened the window, it was completely different. I said, what the fuck?
Yeah. And you thought, I'm not getting out of bed.
Yeah, no, and I woke up like 20 minutes ago, so I said, no, I will have no time to get my bicycle, right?
All right, I don't know what's happened with everybody today, but there's only 4 people in the class.
4 people.
4. 3 in the class and you. Carolini was
Oh,
here,
Jeff,
gone.
I was supposed to be in the class as well.
But where's all the
Yeah,
online people gone? I don't know.
Yeah, we have 15 online, 16, yeah. They should
Really?
be. Yeah.
Oh, wait. Ah, look. It's not showing up on the view. Only this, I got only this one speaking was being shown. I see it.
Yeah, because for me it's showing like 16 participants.
Yes. Oh, there's loads of people. Hey, everybody. I thought I was just here on my own with a couple of guys and now a lady. Right. Today is going to be a bit random because I haven't written any slides. I spent an hour last night researching what to do, and I couldn't work out the difference between what I know as a database administrator and what a database person needs to know in business. I know what I do in terms of looking after databases. And let me explain what I do in the business worlds as an IT person. And then I'll try and explain what is it you're going to have to need to know as a business person. Okay. So I'm on a different PC, so I don't have the SQL software again. And I have the workbench, but when I try and connect to a database, there's no database, it's not there, there's nothing. So I can't really show you any of those tricks and tools. Unless I can connect to one of mine online. But I'm not sure whether I can remember my connections. And I can't put my PC on here because there's no adapter for me. So it's a nightmare. Wait. Let me just check something. No. Ancient fucking PC. VGA cables. Who connects with VGA cables? Everything's HDMI, right? Nightmare. Okay, so there's going to be a lot of whiteboarding and me showing you stuff from real life, but not actually doing anything with the computer. What I'm going to do is I'm going to go to Harvey Norman and get a VGA adapter for my PC, and we'll show you some real stuff next week. So let's see if I can turn the lights down. Oh, Jesus. Yeah, that's the lights down. Okay, so I'm going to share the screen. Oh, wait. Have you all got the QR thing? Have you done that? Okay, so we've done 20 minutes of the class and done nothing. Right. So let's shrink this down. And how do I make this big? All this shit's in the way. Move that down here. Make that big. Okay, so databases. We know that databases are drawn like this, right? Which is a container of stuff. And in here we have a set of tables with rows in it. Yes? And there can be many tables. Okay. We can then write a whole load of queries and save those queries as procedures called stored procedures or functions. So a function would be like you would do in mathematics. The function of x equals this times this times this times this. Okay. In database world, the function is to process a particular table in a particular way. The procedure, however, is a number of steps that we want to take onto the data. And that might be processing data inbound or processing data to be removed. The procedures would normally call the functions as they need them. Okay, so functions are repeatable actions. Procedures are tasks that need to be done on the database table. So here's our tables. I'll just put tab because it's hard to write with a mouse on a whiteboard. Sometimes there's also indexes needed, which is kind of like a lookup table to be able to find data in a table in a different sort order. So this is an index. I'll just put IDX. IDX. Index. So if you've got a table that's organized by student number, that doesn't help us trying to search by student name, right? So if we want to search by student last name, the student number index sort on the table doesn't help. So what we do is we take that index number here for the student numbers, and we take the names. We now make the names the first column and sort them, but keep with it the student number. So now we can look up the student name, find the number, then go to the table and find the record. Yes? So indexes allow us different ways to view the table. So these are the objects that are stored in the database. So this is the database. The database also has a thing called a transaction log or redo log, depending on the database type. I'll say it's a redo. Microsoft say transaction log. Oracle say redo logs. And the idea is that as our users are entering data and doing transactions, so here's my laptop, and I'm entering in an order. So I'm filling in the order. And to be able to fill in that order, to see the order, I've had to find the customer name and the products. And this is what we call master data. So in the table, there's a table of customers, there's a table of products. When I'm doing an order, I'm doing a transaction where I'm linking a customer with a product and making that as something that they want to buy. So the order is actually the transaction. So what we're trying to do is to save the transaction. Now, during this process, data is being sent to me from the tables that a customer needs a number of products, 1, 2, 3, with their quantities and prices. As I'm doing the steps to create this, the steps that I'm asking the database to do are being recorded in the redo log. If I actually press enter at the end, this sends a special command to the database called commit. That means write all the previous actions to the database. Okay. So what we might be doing is changing an order, bringing data up, changing data, but then we might choose to cancel. And if we choose to cancel, instead of a commit, what's the word for cancel? The database word for cancel is rollback. So the alternative is rollback. And what that means is any data that we changed in this section here so we've got changes are undone. Okay. So we need to have the redo log to go back up the actions and put the values that we changed back to what they were. Okay. There are various different strategies for doing that, depending on the database. Usually, we have a scratch area of database. So they're called different things in different databases. In SAP, they are called the, doesn't matter what they're called, does it? We'll call it the RX tables, RD tables. Okay, there's a number of tables called RD, RD star. And as we make changes, we pretend that we're doing the table changes in the real tables, but we don't. So these changes are entered into the redo log and into these temporary tables. Why is that? If we lose our connection and we log back on again, we still see the same data because it's showing us what's in the temporary tables. Okay. Also, this allows the server to disconnect you and reconnect you. There's a reason for that. I'll come into that in a second. So the commit then takes these temporary changes and puts them into the real tables. That's what the commit does. So the commit says, take these entries and write them into these tables because we definitely want to save this change. The rollback, however, just marks these as being redundant and can be overwritten. And that's all the rollback does. But we also put an entry in the redo table to say rollback, which means that these are not considered for a redo in the database restart. So that's a lot of database technology that's going on. Why? Okay, I'm going to save this. All right, hello. Oh, yes, you are here. Okay. How do I, where's this save? So I can save this and I can put this up on the share, right? Or I can even do one in a slide for you. So I'm going to do clear my drawing and start a new one. So the reason why we do this is because our application server, this is our application server that is giving us the transaction, managing the screen for the order. The database sits underneath that and responds to the requests from the application. The application server then is dealing with me and my order. So here's my order. However, I'm pretty damn slow. Okay. My clock speed is by about every 2 seconds. I do something. The clock speed of the app server is 2.6 gigahertz times however many CPUs. Okay. So it is managing transactions at a very fast rate. So if it was to wait for me, we would be losing 10,000% of the processing power. We're throwing it out the door. So if I hold up a processor while I'm typing and ordering, that does not make sense. So what it does, it uses memory of my session ID. So it stores everything about me in here. So every time it sends the information about the order to me, it sends it, then immediately drops my connection to process somebody else. My session details are stored in memory, so that when I do something else, it says, oh yes, I've got a session for you. I'll bring the session back, and it will say, well, did you finish that order, or are you going to make another change? If I make a change, it immediately connects me, saves the session, and disconnects me again, and waits another eternity until I press the next key. So to be able to roll off and roll on, and this is the roll in, roll out process. Roll out. The fact that it can do this allows it to connect 5,000 or 50,000 other people on their processing list. Yeah. So these big servers can multitask many people. Multi-task. And the way it does it is that it saves where we are in every transaction to memory in a flash. So we want a new screen. The app wakes up, gets the session, sees what we want, throws us to the screen, and puts us back on memory. We type something, we press enter, the app wakes up, gets the session, looks at what the enter means, and it says, okay, and gives you the next screen until you've finished. At some point, you will issue either a cancel or a commit, a save. Okay, at that point, it will wake up and do something to the database. So in the meantime, our database has to keep track of the changes we make until we get a commit or a rollback. So this is the scratch pad that the database uses to save and return from, and what we know as the RD tables. To keep track of these changes, because we don't want to write to the main tables. So there's our main tables. Until we finally know whether this is a save or not. So we use the scratch pad in the RD tables. If we get a save, we put the RD tables and we write it to the real tables. And this is called an update. And there are different processes on the machine here to work out managing dialogue processes to and from the people, and update processes to tell the database to process these. In case the power goes off at any time during this process, we need to, if you've got 50,000 people halfway through processing and you turn off the power, we don't know what state the database is in because we've lost the RD tables. Yes. So we don't know what real tables should be updated or not if the power goes off. So this is where we have the transaction log, T-log, or redo log. It's purely for point in time recovery. So here's all the semi-transactions during a point in time. And here is a commit, here is a commit, and here is a cancel. And this T-log or redo log is written to at least once a second. Okay. But bearing in mind the processing power of this machine, this could be 5,000 different actions every second. Okay. So in here is a list of all the actions that are happening from the users, happening in memory, happening in the RD log, through time. So now let's assume the power goes off. When the power comes back on, the database has to do a thing called a recovery. And the first thing it does is looks for its redo log, and it reads from top to bottom to down. And it refills the RD tables, which are empty, with the changes. If it finds a commit, it updates the reals. If it finds a cancel, it rolls it back, marks it as being useless data, until it reaches the current time that stamp that it went before the shutdown. It then opens the database. The app server has to look at all its cancelled sessions, okay, and try and reconnect back to the users. Okay, it will report to the users whether their transactions were either completed or rolled back. So if there was something that was still in process and it didn't have a commit or didn't have a rollback, they too are cancelled. So we need to update the users. So they normally get an email telling them that their transaction was either completed or cancelled. That lets them know whether they have to do that work again or not. Yes. So in the event of the power loss, then the database is still consistent. That is important. Consistent. That's a promise that we make to users that nothing will be left half and half. It'll either be fully done or totally undone. We then send an email to them saying it was either totally done or totally undone. So there's no gray area. And that means that we make sure that what's in the database is in a fixed state. So the application server then writes to the redo log or transaction log every time it does a memory change. So we know what's happening in the database and the database RD tables. And if we lose power to the database, we can recreate that state that we're in. Yes, that's database technology in detail. Why do I do that? Because as a business, you need to know what are your recovery options in case of a problem with the database. And the IT team will come to you and say, what do you want me to do? Okay, you need to understand what that means. Okay, so if I clear my drawing. So let's assume then this is time. And there's a lot of work being done. And every now and again, I do a backup. So normally this is nighttime backup, right? So we do a backup of the database, backup, backup, backup. So this might be Monday, might be Tuesday, might be Wednesday. And in between times, we make all these redo logs or transaction logs. Once we do a backup, that resets the counter for the redo logs. Okay. So we start again with fresh new redo logs. So let's say that the database goes down here. Okay. We don't say that it actually goes down, or we could say that there was something happened here. There could be a virus, there could be a mistake, somebody presses the wrong button, and we have to recover to this point in time. Okay, so we need to do a point in time recovery. So currently we are here. We're halfway through Wednesday at 10 o'clock in the morning, 10 a.m. So there's all the nighttime logs to go through. And our database has got a whole load of changes in it. Okay, so all the nighttime orders have been processed, they've been sent for dispatch, all that sort of stuff. But something critical happened here. Okay, and you as a business have said, okay, we have to go back to where this point in time was. So how do we actually do that? So we've got a database that's, I don't know, several terabytes, say 2 terabytes. That actually lives on a file system. So every database actually finally ends up on files on a data store. So say, just for sake of argument, that this is a disk. I mean, it could be memory these days, but let's just say it's a disk. Right? So you've got a file system, and you've got a file called SP1. That has got a file in it, and inside there's some different table areas. Then we have SP2. That's got a file, and that's got some alternative table areas in it. And then we have SP3 and some more tables. Okay. We can't read these files, they're database specific binary files. Okay, but they are still files on a server in a data store. That's what the databases look like underneath Oracle or SQL Server or whatever database you think of. And you're going to have 2 terabytes of these files. These files will be spread across many disks and many tables across many table spaces. One of the main things as a database administrator we have to do is to make sure that we space these out. And we normally want to have a CPU managing one table space. So if we've got 32 CPUs, we want 32 table spaces. Yes. If we've got 64 cores, then we want 64 table spaces. So that when we're working as a database engine, we have one CPU managing one space all the time. That makes speed. You don't need to. If we've got a number of disks, then we want to have as many as possible to spread these out, because the disk speed is the slowest thing on the planet. Okay, thousands of times slower than memory. And memory off chip is thousands and thousands of times slower than memory on chip, on the motherboard. So database design then is about throughput. How do we get data on and off of this platform as fast as possible? as well as that, we have a separate disk space for our redo logs. So they can be accessed fast as well and by multiple processes. So here's our redo logs. R1, R2, R3. Okay. So if we want to recover to the point in time, we have to reset these data files. Effectively, we say that they're empty. We don't actually drop them and remake them. That will take too much time. We don't zero them. We just reset the pointer to be the beginning of the file of each file. We then reload the data from the backup. So let's presume this is a tape because it's easy to think of that. The tape holds each disk area and table space, and we replay those until the last backup. So that gets us to this point. So after 3 or 4 hours, we can get tape to reset all the data files to that point in time. Okay. We then use a different tape to reset the redo file from this backup to this backup. Okay. Because that's what's on the tape. You can't choose a tape that's halfway. So you get the between backup redo log tapes, and you replay all of those logs back onto these disks. Okay, and that's going to be another 1 to 2 hours. Depends how many transactions. At that point, we then say to the database on our database startup tool, startup database new to this backup date and to a point in time which will be date time. So you'd say 10:32 a.m. Yes, some point in time. So you put your date and time. The database now starts up, resets all of the pointers because the pointers were at this point. It resets all the pointers back to here and starts replaying all the transactions as if the users have done them from the redo logs to that point in time, and then they stop. And anything that's undone at that point in time in the redo log is rolled back. We now can open the database exactly at the point in time that we specify. Can you see how that works? So what that means is we have to take regular backups, and we have to manage our redo logs to make sure that they're always available in case of some kind of disaster. Okay, I'll save that. The next thing we do is here is our main site. So here's our main app server. It's not very good writing. And here's our database. And here's our store with our files and redo logs. And there's our users. Now, what's happened here is that this system gets hit by a virus. That virus wakes up and encrypts our data store so that we can't get in it, like the health service. As soon as that's encrypted, the database stops running, the apps stop running, and I can't work. Yes, I'm goosed. But in the meantime, I've done some sneaky backup stuff in my secondary site or my DR site. There, I have an app server. It may not be as big and fancy as the main one. And we have a database server, again, kind of smaller, but essential services only. And here, this database has a store. And this has got our backup in it from some point in time. So that set the files for the main database. And what I've done is I've got a fiber optic network and I'm sending my redo logs down here. Okay. And I put that into a separate store for redo logs to be applied. I've got a restore process permanently running on here to replay redo logs back into the database. So this thing thinks it's doing a database recovery all the time. So this is in recovery mode. So this is assuming that there's a point in time recovery and we need to replay the logs to the point in time. Yes, but we don't specify the point in time. Every 2 hours, I move redo logs from here into here. And it goes, oh, I've got to recover these redo logs. And it puts those changes into the database. Yes. So this database is exactly the same state as this one, but 2 hours behind. So the moment I realize that there's something wrong on the main site, I break the link and break the recovery process. And I've got 2 hours to do that. That means this database is still intact and is not affected by the database, but by the virus. This is a totally different network which nothing on the main system can see. So no network traffic goes across here, so the virus can't get here. This is on a totally different network, totally different numbering site. This may be connected to the internet. But this one is not. So this is clean. So at this point in time, I've got something I can recover from, providing I've broken the link and not replayed the redo logs with issues in them. Okay, so the virus may have done a database action to do encryption with their own key. If we do that action of doing the encryption with the key we don't know about, then we lose our database here as well. So we've got to stop that. Okay, so now we know that this main site's dead. If it's malware of type encryption, this will be coming along with a ransom note. Pay us money and we'll unencrypt it. Okay, so there's no way for us to recover this. Okay, so, but we can recover this. So at this point, we can turn on this server and log into it, providing we go to the disaster recovery site and start working there. So our emergency response team go to our DR site and log in and check that everything's okay with that database. Yes? So it depends what business we are as to what our essential services are. Okay, if we're a shopping supermarket, then our essential services might be to get things on lorries and send them to the store, and to be able to do the store point of sales transactions, get the tills working. Okay, so our DR site will be doing tills and warehouse. All other functions will be shut down, because this is the only things that are essential to keep the business running. Yes? Agreed? Essential only. Okay, so we have a slight problem in that the tills and the warehouses are pointed to this IP address over here. And if we put the DR site onto the internet, then we're going to have a different IP address. Okay, there are fancy things we can do with hardware to make the network convinced that the DR site is the same IP address as the original, providing we shut down the original. Do we want to do that though and invite another attack? So what we might have to do is to go to the tills and change all their connection data from the main system to the DR system IP addresses. That is a architectural decision. There's two ways to do it. And it depends on what hardware, networks and infrastructure you've got in place as to what that decision is. But in this case, I can get that system back up and running. Yes, I have got a direct. So why didn't the health service have one of these? Because they wouldn't buy one from me. That's why. And these systems that they had were too old. So that meant that the virus was able to get in because there's so many holes in this system that they could attack. Okay, so I'll save that one. So what we've got then is a situation where the main site's down and the DR site's very busy. But what we've got on the DR site is an app server and a database that's now operational. We've brought it online. And we're recording transactions in that. So we've got apps. We've got our store and our redo logs, and we're now creating new redo logs. Okay. So we have to make sure that they're saved in a separate area when we need them. And we've previously got the backup that we used on a separate file to start this, the backup file that this was created from. Okay, so we have the backup file that this created from. We got the redo logs that we were transferring from the other system up to 2 hours before. And what we've done is just put a red line over the 2 hours ones. So we've got the old redo logs, and we've got the new redo logs. And we've got the backup file, the old backup file. So we go back to the main site and we wipe everything. Okay, total wipe of everything on this network. We can disconnect the main app server from the main system, from any network. We turn the firewall off that gets into here. So this is a clean area. We make this totally clean and start from scratch. We get our database. and we empty our store because it was encrypted. So there's nothing here. So we totally wipe it. So the first thing we have to do is to reinstate, once we know that this is now clean, we reinstate the fiber link. And we bring back the backup. So we put the backup back in that we used to make the DR site. Yes, now we've got our files back. We then replayed the old redo logs up until the 2 hours before. Yes, up until the red part, and then we stop. Okay, we then open the database for recovery. Okay, so we now start replaying those redo logs into the main database. But we don't open it at the end of that. We then get the new redo logs and play those in as well to bring it up to the same point in time. These are old. There's the new. So now we're matching the system backwards and forwards, transaction for transaction. Yes. At some point, then we schedule to break the fiber again and bring this back online. We now have the main system rebuilt. We put the DR site back into recovery mode. Yes, so if there's a transaction here, it's stored and we go this way again. But that means we've then got to put all of the and the office reconnected onto this new database that we've built. But obviously we want the office to be clean before we connect it to our main server. So we have to sweep everything. But that's a way we can recover. Can you see that? The key points for the business are, when do we do the thing, right? The business decision is, when do we switch to DR? What can we do when we're on DR? And at what conditions can we return back to the main? And if we return back to the main, what do we have to reconnect? Because these systems aren't in isolation. Okay, we also have other app servers that will have been affected. So here we have the HR system. Here we have let's see, so a separate payroll system. Here we have our data analytics systems. Okay. And here we have our Windows Server, Active Directory for logging on and logging off. So our actual disaster recovery process has to cover not just our main application, but everything, right? We may do different levels of money depending on the criticality, but something has to be stored over here to be able to recover something over here. Yeah, we will put our main money in our main system. So it's quite a lot to think about in terms of keeping the business running in the event of a disaster. The disaster would be something like the server room flooding, the ceiling falling in on it. Okay, there being a fire in this room, or some attack
like a malware attack that kills all of the servers on here, which is more likely these days. 20 years ago, it would be more likely that a flood kills your systems, or there's a main power surge, lightning strike or something, and that will cause the issue. Less these days, because we put them in fancy data centers, which are bomb-proof, yeah? So save that. So let's have a look at in terms of the business situation. In terms of the business then, what are we concerned about in terms of an attack? The main thing we're concerned about is continuity. Why do I pick a long word to spell with the mouse? Continuity. That'll do. All right. So how do we keep the business running while the systems are down? It's not necessarily the case we have to have a computer. In the case of the supermarket, when we got the DR site up and running, we printed the day's picking lists, sent it to the warehouse by car, because the warehouse we didn't know was compromised. We've only got one warehouse. We don't have a disaster recovery warehouse. So we sent the picking list by paper to the warehouse, and then they started picking from paper and filling the lorries and sending it to the store. So it doesn't have to be electronic. It's whatever the continuity is that we need to do the processes in the event of an attack. Processes. So that means we need first a policy. The policy should say we need policy. We need a plan. That plan will then have a whole load of procedures. I'll just put procs. That tells us how to build the DR site, how to turn over it from one to the other, how to get it back again. What if it's not a full disaster and it's only a partial disaster? Other sets of processes. Okay, and we have all these in place. And then it's who's going to do this? Okay, so the people like me who are the database administrators are the people that you need to do the recovery. Okay, you can't get somebody from outside that doesn't know the intimate way in which the system is built to be able to use complicated recovery tools. They are complicated. Okay, they do fancy things, but you have to practice. Okay, so typically we practice once per year a full DR scenario. And that can be a real ache because it takes 2 weeks in preparing for DR and then about 2 weeks to recover from a DR. Even though it's a practice, it's 4 weeks of effort to try that. So 1 month out of every year is on practicing these routines. Okay, not everybody wants to do that. So we could outsource it. So it could be internal or external. The way I like to use the resources, I have 2 teams. Okay, I have the external team to secure the networks because they do that every day of their life. They're experts in networks. Okay, generally speaking, as a database engineer, I touch a network once a year during my practice. I'm not an expert. Mainly, I'm trying to keep the database working. Yeah, and I'll go into that in a minute. I want to be the internal that does the database recovery. Who cleans the office systems? Not me. I'm too busy doing the databases. I get an external team in, like a carpet cleaning firm. Yep, buy them, get them in. They're experts in the carpet cleaning, clean my carpets. I don't know how to use your carpet cleaning machines. Yes. If I've got an antivirus sweep team and a PC recovery team, they are expert in that. Buy them. Right? They'll do it 10 times faster and 15 times better than I could. And by the way, I'm still busy doing this recovery. Yeah. And so are all the other people that are normally internal. They're focused on recovering systems. So the key people I use for external are for the cleaning and the networks. By networks, I mean the very complicated processes of moving the IP addresses of 50 servers on the main site to 50 servers on the disaster recovery site. Yeah, that's a lot of network changes. We have to reboot all these machines, and we have to go into the internet, change things, or we have to go to all the various sites and change networks. It's a lot of work. It's not easy to, okay. With virtualization, it's a little bit easier because we can change network addresses on the fly, but all of the hardware has to change. Nightmare. So I get an external team for that. The internal are concerned about recovery of essential systems. So the internals are looking at essential systems, recovery of those systems, to be able to do the continuity. How do we keep the business running? If we don't keep the business running, the company may fail. The whole company may shut down because of this kind of situation, right? So this is the kind of business processes we have to set in place. And the business will be guiding us as what is essential and what isn't essential. Because me down in the IT farm, we've got 50 servers and we don't know which is the most essential to the business. So we come up to the business and say, well, what do you need to make continuity? Do you need a printed output or do you need a full-blown server? And if you've got a full-blown server, what does it have to connect to? Okay, because things don't always work in isolation. So there's a fair amount of work in here. And then the business has to run around using just the essential services that we've got to be able to keep the thing running. So it's got to tell everybody in the world, all of the users and all the external people that log in, that there's something wrong. Yeah. Aer Lingus website. They didn't put their telephone system on their essential services. So they couldn't ring up people and tell them that their flights aren't running. Duh. Who are these people that do these things, right? Why don't they get some expert like me that's done it before and say, what is your essential business process in the event of the system going down? And the essential business process is we have to tell people things. Okay, you need comms. Comms is now an essential part of our process. The booking website isn't. Okay, we've got to tell people something's wrong. If you don't tell them, they can't make alternative plans. The second thing is to bring up the website. How long did it take them to bring up the website? A long time. However, their system wasn't actually down. It was just disconnected. So why didn't they have a backup network link? Okay, so what I had on my supermarket was I had a main site and that was connected to the internet via fiber optic link to a supplier. But I was well aware that that's one piece of fiber coming in off the road into my building. If someone was to dig up that road, I would lose my connection. So I went on the roof and put a microwave dish on there. Up in Three Rock on the mountain, there's another microwave dish that was listening to me. Beep, 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 all the time. That was putting me on a separate fiber. So in the event of my fiber being dug up, my microwave kicked in. Ta-da! So why didn't Aer Lingus have one of those? Do they not understand how networks work? Nightmare. So I could have prevented the Aer Lingus outage. I could have prevented the health service outage as a database engineer and knowing how the business needs to work. Yeah. So what is essential to make this work? Essential is that we have a plan. And underneath that plan, we have the processes. The plan tells us that we must make these things. The processes tell us when to change from one to the other and what we have to do to make that happen. Make sense? I just can't understand these days why people have sites that go down. Okay, so database administration. Here's our database. We know that it's got redo logs. And we know we've got storage space on the store. So what is this database here then that we talk about as the database? I might have said that this is part of a DBS, a database system. The database system has a thing here. Oh, I've done that wrong. Undo. This here is a database management system, which manages the data going in and out of database. This here is the database system, which is all parts of a database. This is just the management part. So this is where we create database users. This is where we allow the updates and the models. So the models, the updates, the users. So the database management engine is what we connect to with the workbench. So the workbench connects to the database management system because we know we can connect to database tables. We know we can create models and we know we can enter and delete data. So we have to be connecting to the DBMS. The database as we know it is actually the thing called the schema, which is the implementation of the model. We know it as the database name. So we created a schema called college, but as far as the outside world is concerned, the whole database is known as college. Yeah. But it's actually the schema that's called college. Technically, if I'm being totally pedantic. Yeah. Because we could have alternative schemas in here and therefore alternative databases. So a database management engine can manage more than one schema. Therefore, it can manage more than one database. That's why it's a database management system. Inside then we have the database. The database then is a set of files with things called table spaces on it. I mean, you might have just one file with one table space, but sometimes, mostly it's more than one. And then we have our redo log space over here. So what do I manage in terms of the database as a database administrator? Okay, so this is our storage. The biggest thing we have to manage is, do we have enough space in the store? Because people are making data all the time and filling these things up. So space is my number one issue. Okay, so every time I do a backup, I have to make sure that the backup has enough space to take the files. I'm going to call it a tape. Nobody uses tape anymore. Well, not many. But if your space gets too big, then you might need to have more than one tape. Okay. When I was in the supermarket some 10, 15 years ago, I can't remember, we were consuming 5 tapes for the database. Okay. So this space was getting so large. And then I need another set of tapes for the redo logs. Yes. And I might want to send those across a fiber optic network to some other space and make sure that they're being recovered. So no, space is one of my major issues. The other thing is, where are the tables? Okay. If I've got one table that's particularly big called the material table, so everything in the whole company is around 2 things in the college, isn't it? Students and courses. Yes. So if this is my students table and this is my courses table, my database engine is trying to get to the same tables all the time. Okay, as these get bigger and bigger and bigger, and I've only got one CPU going to fetch these bigger and bigger tables for the students, what I might want to do is to split them. So I now put half the data in this file, and then I'll have a student 2 file. And now I start writing all new records for students into the student 2 space. That allows me then to have more than one CPU busy on the student table. So this is load balancing. Okay, I want to get more load through my storage to my database engine because my database engine is as powerful as hell. Yeah, it's got many CPUs, lots of memory, but my storage is the slowest thing. So my storage design now is important. Do I have enough space, and do I have enough files for the number of CPUs? Can I increase the number of CPUs? Can I increase the number of files? And can I split my data across multiple files? So there's a lot of things to do in terms of this to share the load. Save that. The next thing would be is if I've got more than one database. So here's my database engine. My DBMS. So I'll give it 2 database management engines. DBMS, but a shared store. So now I've got many files. So I go in powers of 2. So I go 32, 64, 128, 256 in those sort of powers. So I might be up to 256 files now on my store. And I've now got 2 database engines managing an application server with a memory, a shared memory. So I now have shared memory that the application servers are now talking to. And I have between 5 and 10 application servers connecting to this shared memory. So this does a couple of things. If one application server goes down, we don't care. If one database engine goes down, we don't care. The storage we pay hundreds and hundreds of thousands for not to go down. They have dual controllers and dual storage and what we call RAID, memory RAID. So this data is actually not in a single file. It's spread across multiple disks or memory areas in bit form that's represented like this. So I'll give you a clue. There's a RAID of 3. If I'm writing some data, I write part of it here, part of it here, and I put a checksum here. A checksum here and a checksum here. If this data goes down, I can recreate that data from this data and this checksum and put it back on here. So I don't need all of the disks or all the memory areas. By putting extra information across the disks, we stripe it across the disks, recovery can be done from missing disks or missing memory sections. So if something goes down, we've got a self-healing storage system. Okay, what happens in the data centers is you get a memory store with a red light. You pull it out, you put another one in. It flashes green and then goes solid green, and then it's recovered. That's all we see. Yeah, but what's happening is that it's gone over here. This goes red light. We put in a new one. It sees that got a new one, and it puts this back in here and turns this one off automatically. So it's self-healing systems. So that could be spinning disks or memory cards or whatever. In terms of the database systems, we have multiple power supplies. We can have 4 power supplies in here. You've got multiple memory stores. The memory is also arranged in self-healing, so that if any of these parts of the servers go down, they go red light. A warning comes up on our big master board in operations. We go to the store, we get the spare part. We go into the data center with a big woolly coat on because it's cold in there. We go inside the cage, we swap out the parts, and then the system auto recovers. Yeah. And that's what a cloud system looks like. Okay, that's how we build a cloud server. Logically, in terms of tin, it's normally a big chassis like this, big chassis, about this big, that wide, that fits into a cabinet. And we put slices of servers, memory, and storage into it, normally 12 slots. So I could build a database, a storage system, an app server on one chassis. And typically then we would have the spare chassis, one side by side, one database here, one database there, or they might be in separate cabinets, separated by half of the room. Okay, so this is how we make online cloud systems pretty much bomb-proof. Yeah, you don't see downtime because of this. That's my database safe. It's resilient, so it can have things go down, and it's consistent because of our database recovery systems and our online redo logs. All good? We'll take a break. Okay, let's take 15 minutes. It's 2:30, so 1:45 return. Okay. How do you think that went in terms of understanding the databases in the real world? Yeah. Better than doing how to do a model in the database, how to do analysis. And we will have to do something. But what that does is give you some insights about where things are in the overall scheme, what we have to do as business. Yeah.
IT can make no decision. When someone comes to me and says that, or I go to the business and say, I need to work on this database. I need to update this database and patch it. The business will tell me where I have to do it. So I have to go to the business and say, I've got to do some work. And I'm doing it. Not at the beginning of the month when I'm doing month end, sort of for 3 days. And we'll go on there. Yeah. It's all about working around the business. In terms of the transaction fee and how we use the database, then companies are saying this is slow. We then have to do analysis on what part of the system is causing that slowness. And then solve that by doubling up something to make it go faster. Constant challenge with these things. Off again. Coffee time. Open the door. Let's go get coffee. Coffee.
Wait, concentrating what you say.
Um,
Was trying to and then
that's hard because I'm tired, which keep my hopes with it. Because sometimes I especially using a noise, then when the light on being the noise. And when they come back, I lost what's happening.
for me, when you talk, you have to show the actual. This one,
It's not good, it didn't like. A lot of information on it's more.
put all these things, you know, like a print screen and then.
I think it's really good. And exactly. Doesn't know how to share.
It's good. I really want to share that.
You sign the list. The list for.
Did you get?
Yes. Are you?
Actually, you already because,
Oh, yeah, it's here.
yeah, it's already clicked actually.
They check it. Because sometimes they send to the group the picture for them.
Yeah.
So I don't know if they do kind of double check. Because
They have to go to the.
this, if you scan the barcode and you don't have your name there, so you will not receive it. But that is.
The link is working.
Yeah. Oh, yeah, they have, it's, no. The cop they have.
Mhm.
Mm.
Like fighting, no? Wonder. Like a new one here?
That's better than the livery.
Yeah, better than I believe, yeah. I would.
Be there for it, just stay aligned, that's it.
You know what they. And you don't know.
I'm so disappointed because like. This kind of business used to be my English class, so like, my wife is in CCT and her room's like
Much better.
way better.
And there's, it's cheaper than here.
Yeah,
You like 200.
yeah,
Really?
I don't understand. My agent said that these colleges are good one.
Okay. Did you?
Probably-
Who's your agent?
Probably he got information.
Yeah,
So I remember I tried there and here. And I decided here, because my friend, he had started here before. But a lot of friends that they are studying there, they say that there's.
Probably in Spain.
As for screens, for, no, one projector for screens around. Even the chairs, everything.
You know what I'm thinking? This is not our permanent class. Because they didn't send email. The classes in 205. You know when you send them message in the.
I will tell you everything. They thought I was attending online class. And then I had to explain, no, it's 205. I came here, some guys were reading this stuff or something. And then they saw. But I think it's yeah, no one told us it would be like, yeah.
You know what I'm thinking? They will switch the classes around. So that's why they did send email, because usually they will send email.
Next to my person. I think they're gonna keep like this. Especially because the is Did you start there? Sounds sad.
I didn't, I think it's fine.
You guys started the class and. No.
I'm trying to put it in the
It's going for 2 weeks, right? 3 weeks. 22nd.
22nd. Yeah.
It's at the end of. Well, it's not too bad. We have time. No, I'm just, no, I'm starting, but I'm really confused how to answer. Put on.
Look at me. I should be so thin. No. The thing is, when you're fit, right, you consume so much food. And when you then stop doing fitness and keep the same feed,
Yeah.
then
That's good. I don't think
but I wasn't that far off. This has come from £1 a year. Over 20 years. So this is £20. This is a small amount. And it's less on that exercise.
I have the same story, but it's about 5 years. I have to play football 5 times per week. Go to the gym, then I had a on my knee.
Yeah. And then.
And that's many information. The metabolism,
But
that's lower.
you are not burning. And then I was, yeah, I'm screwed. I try and do good, try and do good, and then I have a real blowout. Biggest, yeah.
I don't know you, but when I get issues, I go to food.
Yeah, yeah.
I'm sad I go to food, I'm happy, I go for food, it's all about food.
Yeah, some people go for drink, some go for gambling, some go for sex, some go for food. Whatever it is, you try to escape whatever stress and tension. Sure. I'm bad, I get all of them.
The one usually who goes always says that word, I'm bad in everything.
You're bad in everything, right?
No, I said usually who does everything
Oh, yeah.
is the one who says I don't do anything.
Yeah. I mean, I used to train seven days a week. 4 of us. So 3 hours every night. And then ballroom dance is basically a 2 or 3 minute sprint. And you're on your toes, you're going around the room sweating. And at the end of it, you're sweating and you're gassed. Do that for 3 hours. I went to football training, football selection for Leicester City. And they had us in a cycle velodrome. So they had the cycle walls at the end, and then a football pitch in the middle. So Leicester City would use this to select the kids for their training program. So I was 15, and there was a bunch of us, probably 20 lads, 25 lads. And there's been selected from the schools. And they said, wait, we're just going to check your fitness. And I decided the velodromes was the stadiums, which were concrete steps for about the time. Because they haven't done the seating in those. So they said, run up and down those steps, back to the pitch, round the pitch, up down the stairs, back, round the pitch, back. So I arrived back and I was just going, not even breathing. And then a few minutes later, the others are collapsed. And they said, well, what do you do? I said, you want to be fit, you be a dancer. So even though I was a soccer player, they used me because I could run around. Didn't have an awful lot of skill, so I didn't get into the system. But most of my, whenever they wanted someone there, just be there because he's got all they need to get. And I was an absolute and flying the ball in to the people in the box. So that was my thing. I did have one amazing shot from the halfway line. I love that. I think of that all the time. And another one, about halfway on the right hand side, the ball would come from the chest of it and left foot in the field. What? Could I do it ever again?
But people that kind of footballing door or just people that footballing door? Because football, because we have Brazil, it's really popular kind of footballing door.
Oh, indoor, no, outdoor.
Oh, okay, okay.
This is a full size. But mainly after my job was just the ball over. Occasionally I find myself in the wrong place and had to shoot. Mostly it was everywhere. The ones that you get, you remember.
You know what guy football no?
Huh?
Oh,
Very football.
yeah.
I did. I mean, I went last year to walking football. So walking football is done on it's an indoor pitch size, but it's outside. You know, the courts on the AstroTurf. And there's everybody from like 60 to 75 out there doing this walking. But then two lads that turned up in their 40s and they wouldn't walk, they ran. And I complained to the organizer and he just said, if you don't like it, leave. So you can't have one rule for the old people and another rule for the young people. I just disagree with the argument. I tried swimming for a while, but I was good for 2 months, and then I couldn't be bothered a long time and stopped. I'm basically a lazy bastard, unless it's something I want to do. And then I won't stop doing it. Now, what time is it? Is it time to start? Yes, it is. Okay, we're back. Now, so everyone now understands why Jeff's fat, because he's a lazy bastard. Doesn't want to do any fitness, but still wants to eat the same big size dinner and all the sweeties. Damn it. Okay, so the next thing we need to know about databases. How long have I got? Half an hour? 40 minutes. Okay.
So I've done the storage backup failover design of the infrastructure. We've then got the software. The main software that we have is MySQL and its family of systems. So this is about database types. Get in there. S. Database type. So I don't like orange anymore. I'll go back to blue. So in database types, we have this thing called OLTP. Anyone know what that is? Anyone know what OLTP is? I would have said it before. Online transaction processing. Transaction. Processing. Let's see, whatever. It's got a G on the end. And then we have OLTAP, online analytical processing. So this is for analytics, online analytical processing. I'll just put analytical here. Analytic. Okay, so this is what we used to call business intelligence or business warehouse or business information systems or whatever it is. So it'll be either warehouse or intelligence. So what I've been describing so far is online transaction processing, because I said we were transacting orders and things, yes? So what is OLAP? Here is our online application transaction process database. And I'll put it in its normal thing here is that here is a database, and that's supposed to represent the entire database system. Okay, so all the other bits are inside here. In that database is the tables in order number. Okay, but we want to do a report not by order number, but by product and date. Now we can either create a whole shed load of indexes in here, which will double the size of the database, and then use that processing power to do reports. Or we can export the data out of this into another database in a different format. So we extract, transform, and load data into this new database, which stores it in cube format. So this is a database, but it's for analytics. So what we do is we look at all of the orders, we extract it, and then compress it. So if you've got a whole load of orders and you've got the shop reordering system saying, I want 24 Weetabix boxes, please. And now I've got 22 stores, all ordering Weetabixes at different numbers. Over here, we just have one number. We want to have 300 new Weetabix boxes sent out, please. One line. And then we'll do that day by day. So we've got by product, by date, and a number. It's compressed. So we don't have to search the entire table of products, the entire sales orders list, and work out how many Weetabix we've used, yes? So now in this area, we can look at products this way, we can look at dates the other way, and we can look at numbers the other way. You've got three ways in which this data is indexed. we can now run reports. And this is the main thing for a business information system. So the whole thing about reports is that this is going to provide us a graph over time that we can then put onto a dashboard and then give to managers. Okay. So the whole point of analytics in this sense is to provide reports on compressed data so that we can see whether we have a trend of increasing Weetabix sales or we have a trend of decreasing sales. Okay. And that might make us have a different effect on what we put on the lorries going out to the stores, but also from our suppliers. So we want our long-term suppliers to know what's going on with the stores so we can have stock arrive into the warehouse. Yeah. Another thing we might have is waste. So we might have an increasing set of waste values. That might be something like bread or fish. Yes, something that expires quickly. Tins of peas don't really waste. We don't throw out tins of peas very often. However, something that's fresh goes out of date very quickly. If we have a ton of fish come in and nobody comes in and buys it, then we throw it all in the bin. Same for bread. If waste goes up, then all our profits go out the windows. So our manager has to do something about that. They reduced the stock supply to the store, so it levels out to an acceptable waste value. Yes. So all these reports then allow us to look at our transactions in the stores, reformat that data into a set of reports that we can then visualize, that the managers can then act upon to make the most efficient use of resources. Okay, so OLAP is the databases that we use to do that. Happy with that? I think that's the most succinct way I've ever said that. The most simple way of transitioning it. So I'm happy with that. Okay. This is up until the technologies I've just described. Now, there is a new database technology in town that I need to explain to you. Okay, so here we're going to have a pink. No, I don't like pink. Silly. Stay with blue. Okay. So stick with me on this one. You'll need to watch. So here is my database storage engine. Okay. Here is my database engine for queries and for DBMS. So this does two things. This does transactions and it does analytics in the same database.
Josh, just
Yeah.
one question.
Yeah.
I just want to know if we are going to practice with a real database system or just like this, like theory.
Today is just theory. And the reason is the system I've got doesn't work.
Actually, during the assignment of the exam, are we going to practice with the actual SQL website?
Is that what you're asking about today course or about the assignment?
Well, actually, I don't know the general course because it's week 5 already, but I don't know.
Yeah. The assignments currently are being approved. Okay,
So someone will be,
so I issued the assignments to the exam board, okay, for all assignments. I got the first ones back yesterday for some of the other courses. So they'll be available for release pretty soon.
what we are trying to understand is he gonna return or we gonna do what they're doing?
I haven't decided yet. The assignment will be on a real database. The exam will be theory. Okay. So you need to know both. In this one, here, this is the data. Okay. Down here are all the tables. And up here are things that we call views. And the outer layer is how we can do all the connections. So here we have the open connectivity. Okay, so this is databases reinvented. Here, there's no storage. Okay, everything is in memory. There are memory snapshots sent to a backup store and to a redo store. So there is storage available in case the power goes off. And they are memory snapshots and redo snapshots. And these are both done from the memory very, very quickly. And they're done by the central engine here. So here we have information about the engine itself and its tools. So this stuff is the DBMS. And this is the entirety of the database system, DBS. Everything in memory in one place. So you don't need an operating system to talk to a disk store. You don't need an operating system to do a redo log. Okay, so everything is memory to memory. The engine feature is to memory, the data is in here, and the connectivity to the application server is done through these connection blocks here. And you can use any open connectivity. So we can use SQL in here, in this memory database, or we can use ETL to do an extract, transform, and load. We can do database to database connections. All sorts of connections are available around the outside here. It also has connections to the internet for data streaming and to big data. It has other connections for databases outside of this database to make database available in here to our SQL, even though the database is not connected to us directly. So there's lots of different ways of doing this. It can also store Google Map spatial data and non-table type data. What's non-table type data? Well, YouTube data, pictures, videos, all that sort of stuff, social media type data. So this database then can do everything in a modern world. And it does it without a storage system. Well, it's got a store for recovery, but everything is now in memory. What's the special thing about that? Well, what we can't do now is we can't put tables in different table spaces and have different CPUs attached. Well, hang on a minute. It's already in memory, so it's already very close to all the CPUs. So this is a very clever design to use the new technologies. Okay. The interesting thing here is that we only need one database for both transactions and analytics. Okay. So maintaining two systems is a pain. Doing the ETL transfer is a long and consuming task, which can take between 6 and 8 hours. We take that away, and everything that's done in analytics here is done in real time. Okay. Analytics on the other systems, you wait for the next day to find the report. This is real time all the time. Okay, save that. How does it do that? In the old days, we saved data in tables, which were columns of attributes and rows of data. So when we filled in a form, we would fill in our student number, our name, our address, our telephone number, and many other pieces of data that we probably wouldn't fill in. Okay. So unless you were a staff member, you didn't have these. And if you were a staff member, you'd have these and not those. And what you ended up with is storing a lot of empty space. So in an old database, you had to store everything, with it, whether it had data in it or not. So you actually allocated space in the storage system to nothing. When we were doing our separate indexes, the indexes were stored as well. If the database got too large this way, so if you had more than about 20 or 25 columns across, we split the tables into two. So one set of tables, I've had 132 columns for one table. So that would be then split into 5 tables and then joined together with queries. Okay. Those 5 tables would then have 5 indexes. And so we're now multiplying the number of tables, multiplying the number of emptiness and the database indexes that we need to be able to put that data back into the way that we should have had it in the first place. Okay. These databases were designed in 1972. Yes, a long time ago, when we had very small memory and we could only add up columns and rows to 256 because we had 8-bit technology. So all this design of splitting into small pieces is to arrange around an 8K memory page. And that is the size of the data that we would get for the database to process in an application server, 8K blocks. So an application with a program would call from the database blocks of 8K to sort and arrange and find the answers to the query. So the queries were actually done in the application server. The database was just a slave to store and fetch. Yes. We've changed that. So the application server now just asks, go get the data. So it's got one line of code. The database then now stores its data in columns in the table. Okay. And it only puts data in there if there's actually any data in it. And there's a special compressed bitmap here that can rearrange this into table format. This is all in memory. Okay. If you've got 24 columns of data, right? That's fine. I want to do a query on that. So what we do is we create a view. A view is saying how I want to present that. So I say, I want to have all of the products for Weetabix for the last 3 months. So I put the attributes of that in this view. The application server says, I want the Weetabix for the last 3 months. So we go to that view. Our server now has how many CPUs? Remember that data center machine? I can slide in cards of 4 or 8 CPUs. On my laptop, I have 2 cores, an i7, 2 CPUs, and each one of those has 4 cores. I have 8 CPUs on my machine, a laptop. How many do you think I can put on a board in a server? I can put 8 CPUs. These are fancy server CPUs. How many cores? I can have 32 cores on one CPU now. Okay, that costs thousands, but that's how much power you can have. So you got 8 times 32 on a card going in, and I can have 4 cards. How many cores is that? It'll hurt. I'll just say lots, right? Lots of CPU power. And each one of those can tackle this view one at a time. So this view has to look at this data, and it will call upon other views, subviews, to organize the cores of this data. And what will happen is I'll put a core on every single column, for every single subview in parallel. When I've got these all in parallel, I'll put the answers to this view and then give the answer to the app. And I've got the graph. I've got an analytical query online in real time in 0.002 of a second. This would take 30 minutes on an OLAP server. Okay, that's the difference between using the new technology, the new layout of the database, and everything in memory. It doesn't have to go and fetch anything. I don't have to get an 8K block from a disk that's spinning at 10K. Yes? So this allows us to do online analytics, as well as our normal everyday transaction processing, TP. So we need to know that the new technology, SAP S/4 HANA. So what I've just described to you is a HANA database. And S/4 is the application suite that's running on the HANA database. So all of their application data code is now reduced from many, many millions of lines of code to a much smaller number. This database size was 2 terabytes in the past. With the new storage technology of columns only, not having multiple tables, not having any indexes at all, and just having a raw set of tables, reduces 2 terabytes down to 500 gig. 500 gig fits into memory these days. Okay. On my server, I can have 4 terabytes. I don't need 4 terabytes because my engine, my database, and my redo logs and all my tools fit into 1 terabyte. So my entire system now runs in memory. Okay, this is a fancy leap of technology, and it's been a long time coming. It's 30 years in the making. Okay, and it's only been released since 2015. The technology came out. Okay, companies are only now changing as their old software comes to the end of life to this new technology. So only in the last 2 or 3 years are they transitioning to this. And it's a huge transition for them. And it should make their businesses a lot faster. Okay. The information you're getting on the graphs is real time. The tools in the box also allow for machine learning and AI. Okay, so you just put a little side box on, and then here called Leonardo. I'll just put Leo. If you put Leo onto the side of this, then you've got Alexa for SAP. You can talk to it and get the answers out. Okay, so you can put machine learning onto your big production database. So new technology is coming to business, and that allows us to have different levels of reporting. Okay, so this is the biggest takeaway from today. There is a graph in terms of levels of maturity in data processing. So from the very first IBM that was bought as a commercial computer by Lions T in London, we have had the ability to do reports. Okay, so these are list lines. So if you want to do a delivery list, so I want to fill all the lorries with various shipments to go to different towns from London with tea. We can write reports, it will print reports, and we can give those to the drivers. They'll load up their lorries and off they'll go. So from a long time ago, the very first IBM computer could do that. Okay. So most people that use a computing system would expect to get reports, even if they're doing it in Excel or Word or whatever computer they're doing. So maybe up in the coffee shop, they have a computer in there. They don't have a business system as such, but they have something that they can get reports from. Okay. The next level is where we go into the BI and we start to do some initial, what we called analytics in those days, but it's not analytics as we know it today. Business information or business warehouse. This is where we could join one or more databases together and do a consolidation of databases. And we could do our database cube technology. Okay, so we could summarize data and do queries. And we can get information about trend analysis looking backwards. Okay, so last 3 months. So this reports is just current status, yeah? So the difference between the reporting technology, which is normally transaction processing, and here we have analytical processing. We can now do graphs of trend analysis in the past. Okay. We've now still got 3 more to go. Okay. So now we've got to take our analytics a little bit further. And now what we want to do is prediction. So all we're doing then is taking the graph of the last 3 months and then putting a line through it and expecting what it might be in 3 months' time. Yes? Sorry, what's that statement that we are in? Is the process or the structure? This is maturity. Of use of data by business. So this is the level of maturity. And this is what you can do with that. So this is the efficiency of the business, the competitive advantage. I'll put that competitive advantage. Yeah. So the more you have to work on, the better you can do your processes that makes your business faster, leaner, and therefore more competitive than anybody else. Our next level of analytics is to include global data. So now we want to do our same predictions, okay? But we want to put it into a world sense. So here we're predicting knowing everything we know about our business. So we're not looking outside. Here we're putting in oil prices, gas prices. We're putting in social media. So we're connecting to social media, and that means we're doing big data. So at this level, what we're doing is putting our 3 months prediction in context with the rest of the world. So what we're doing is adding context. So it's the same as this, but we're adding context to it. So we're now predicting if the prices go up, as we expect them to do in the next 3 months, and our current sales are at this value, what effect will that have on our sales going forward? If we have to increase price, what happens? Yes, so we're getting some more data intelligence from the data by looking at the world around us, feeding in big data. So what's the last one? That must be everything in terms of analytics, right? So now we take everything that we've got here and we apply rules to it. So now we're doing what we call deep learning. It's not anything fancy, it's just machine learning plus AI. So what we do is we're doing our prediction, we're getting our context here from the machine learning, from the previous, and then we're applying rules to it. So parameters of our business capabilities. So based on what we think the context is doing, okay, the AI will then choose from the business rules what to do. So best action. So now this most mature level 5 in the data maturity level 5, this is what we call a data-driven company. An example would be Netflix. So Netflix are level 5 maturity of data analytics and machine learning. Okay, we know this because they've stolen the best professors on the planet and paid them a fortune to set these systems up. What do? They listen to what everybody's watching on their Netflix platform. What does that do? They look at all the context of the world, their data that they've accumulated, and they're doing their prediction based upon their world values, and then they apply rules to find out their best actions. What is their best actions? Their best actions is what to do with their platform and spending of money to provide more content that they can then generate more money. So all of that data-driven decision told them to create a new detective series. They knew that because their system's telling them they will get the most profit from doing that. Yes? So that is their competitive advantage that Disney doesn't have yet. Okay, so Disney are just putting content out there and it's not data-driven. So someone in an executive space has to make a decision based upon 3 months predictions analysis. Yeah. And they're guessing. The people that are data-driven aren't guessing. They've got good level of confidence that this is going to be happening based upon their data and their artificial intelligence. Okay, so this is something that you would have to recreate or know about in the exam. Okay, so it's one of my favorites. So it will be on a slide. That must be enough, isn't it, for today? I've done a lot. Happy with that? Okay, so we've covered quite a lot about what databases do in the real world and business decisions about data continuity. Okay. The IT people will put the things in place, but only if you tell us what you want. Right? How much can we spend? What were we allowed to do? What is your data recovery time? You want it in 2 hours? It's going to cost you 10 million. You want it next day? It costs you 100,000. Okay, so how much money have you got? How critical and essential is your data? Okay, the more critical it is, the more expensive it's going to be to look after it. Any questions?
Do you have that on slide that are optimized for?
I do have that on slides, yes. But I'm going to do a new set of slides for today's course based upon the whiteboards. So I'm going to put these whiteboards up on the Moodle straight away. I'll then go home, download the whiteboards myself and draw some nice slides. Okay. There are books on all of this stuff. And there's a lot of stuff about data maturity online. Okay, but you will be warned in advance and given time to prepare. I won't just say, right, next week I've come along, here's your exam. I wouldn't do that to you because you're already on catch-up, yeah. But what I've done is totally rewritten the database course to be more practical and businessy. Okay, we're done. Everyone okay online?
Yes.
Well, one person is anyway. Are you the only one awake? Everyone gone to sleep?
No, we are here trying
Okay.
to decodificate all this content.
Okay, next week, bring your laptops or have your laptops at home, okay? Because we're going to do some fancy stuff. Okay? We're going to do graphs from our database. Okay? Bye.
Bye. Thank you, Josh.
Bye.
Bye-bye.